The rapid evolution of reptiles on Earth was probably triggered by nearly 30 million years of rising global temperatures about 270 to 240 million years ago. The age of reptiles was actually born of climate change rather than a previous mass extinction of mammals and other animals, according to new estimates by scientists from the US and Canada. The researchers, led by Dr. Tiago Simões of the Department of Organismic and Evolutionary Biology and the Museum of Comparative Zoology of the American University of Harvard, who made the relevant publication in the scientific journal, Science's Advances, studied the mass extinctions of species on Earth over time and the role that climate change may have played in them, in turn leading to changes in the evolution of new species. The most typical example is the series of climate crises between the Permian and Triassic geologic periods, which occurred 265 to 230 million years ago. These major climate changes are associated with two of the largest mass extinctions in the history of the planet. The first 261 million years ago and the second 252 million years ago. The last one, which wiped out 86% of all species worldwide, was probably initiated by two gigantic catastrophic volcanic eruptions, which led to a temperature rise of up to 30 degrees Celsius. Due to the release of huge amounts of carbon dioxide into the atmosphere. Although the asteroid impacts that wiped out the dinosaurs are more famous, the cataclysmic volcanic eruptions in question were actually some of the most destructive events in Earth's history. Our planet was already on a warming trajectory, but the eruptions triggered an even faster rise in temperature that lasted at least 20 million years. The last mass extinction of species at the end of the Permian period marked a new era in Earth's history, in which reptiles became the dominant group of land animals. Then, during the Triassic period, 252–200 million years ago, reptiles evolved rapidly, creating an explosion of diversity of their different species, significantly influencing the development of new ecosystems. Reptiles were still relatively rare during the Permian period, but during the Triassic there was a real explosion in the number of species, morphological diversity and abilities. Then, among other things, the first crocodiles, lizards, turtles, etc. appeared. Until now, most paleontologists believed that this rapid evolution and diversification of reptiles was due to the extinction of competing species. But the new study attributes the reptiles' dominance not to mass extinctions that wiped out their competitors, but to a steady rise in global temperatures already before the end of the Permian period, starting at least 270 million years ago. As part of a long course of climatic changes and crises lasting tens of millions of years, reptiles became ubiquitous on Earth. Basically, rising global temperatures triggered all these different morphological experiments, some of which did very well and survived for millions of years to this day, while others disappeared after a few million years, Simões said. The study shows how a large group of organisms can evolve and become dominant due to climate change, something highly relevant to today's rising temperatures. In fact, given that today's emission of carbon dioxide into the atmosphere is about 9 times greater than that of 250 million years ago, the question is what kind of impact this may have in the future for the disappearance or appearance of new dominant species. Major changes in global temperature can have dramatic and varied impacts on biodiversity. Our study shows that rising temperatures during the Permian-Triassic period led to the extinction of many animals, including many mammalian ancestors, but also triggered the explosive evolution of others, notably the reptiles that eventually dominated the Triassic period, said Deputy Harvard Professor of Biology and Paleontology Stephanie Pierce.